Let's go into the topic because this is really the most interesting part of this webinar. Let's start high level. What is the challenge with N2O? Okay, well, I was at the Singapore International Water Week a couple of weeks ago, and there were two big topics. Actually, if you summarize this whole event, digital and greenhouse gas emissions. And these two, well, these two combined is actually the topic of this webinar. But actually operating a wastewater treatment plant or designing a wastewater treatment plant in 2022 is way more complex than it was in the past. Why? Because you have to balance all these goals. The first one is your effluent quality. A plant is there to treat wastewater, right? And it started with carbon. Now we have nitrogen, we have phosphorus, and now we are even talking about micropollutants, in some cases in reuse purpose or in Europe for the removal of them. So this is already a challenge on its own. You have to balance it with costs. And now we have this third dimension of N2O or climate impact. These three conflict. No, not a single plant in the world is a perfect plant with all of them in balance. So the cheapest treatment for limited climate and the best effluent quality, it doesn't exist. You really have to balance it. And this makes operating a wastewater treatment plant today a bit more complex, and it makes it a balancing act. So why is N2O important? Well, I should not probably introduce this, that N2O is approximately 3,000 times bigger, let's say, when it comes to climate impact compared to CO2. So yeah, this delivers some interesting key figures. Well, wastewater treatment, approximately, if you look at the global carbon emissions, it accounts for 3% of that. If you only look at N2O, it is a big fraction of this. And in fact, N2O, yeah, they account, including the drinking water and reuse industry, it accounts for almost 30% of the industry emissions. So it's a big issue, right? If we want to lower our footprint. N2O can increase the wastewater treatment carbon footprint with almost 80%, with up to 80%. So there are several papers on that. Where is it coming from? I think most of you also are familiar with it. It's coming from the biology mainly. There are a couple of other sources, but anoxic zones, aerobic zones, biological nutrient removal. What are the questions then? Huh? If you go back to this poll, what are the main questions in the markets? We have broken it down in two big parts. A first one is, how good or how bad are we doing? How severe is the N2O problem? That's assessment. Once you have done an assessment, you can mitigate. What are the questions with assessment? Well, how is the N2O emission at my plants? Which ones are the hotspots? How do I actually prioritize? And how do I adequately do an assessment of this N2O emission? Because it's very complex and it's not easy. Yeah? We will come back to that in this webinar. Very important questions. When you look at mitigation, well, what are the strategies on the market that exist to mitigate? Probably it's very plant specific. So because, yeah, so the question is, what is most effective for my plant? And how do I mitigate N2O without compromising effluent quality? Just remember this balancing act. And what are the generic learnings every utility or my utility can apply over and over again? Many questions we are looking for. A recent post by Water Care Services, which is a utility in New Zealand. Yeah, this is a post from last week on their LinkedIn channel. N2O is not a laughing matter, they said, right? But if you read a bit more in the post, it's all about the challenge. It's really, how do we get the answers? How do we adequately measure it? How do we find the questions we need? We were talking with a Dutch utility customer last week, and they said, yeah, we want to measure N2O in that transition zone, for example, a zone between an aerobic part and an anoxic part, but it was covered and inaccessible with a sensor. There are really many limitations and black boxes when it comes to N2O assessments. So with this introduction, I will give the floor to Ingmar. He will be introducing the N2O topic more.
Okay, thank you, So indeed, I will go a bit further on this topic where the nitrous oxide exactly is produced. So Wim already highlighted that. So you have different microorganisms that are doing different conversions. And usually it's actually under, let's say, extreme conditions. But what do I mean by that? When there's actually a metabolic imbalance. So for example, if you have high levels of oxygen or low levels of oxygen or high levels of nitrites or ammonia, that's typically when the pathways for N2O production are being triggered. And what we will show here is that actually this can happen and actually happens in most of the bioreactors. So when we look at that, what is then driving the N2O production? Well, you have several parts that have an impact on that. First of all, you have your influent that has a certain load, a certain quality, and a certain quantity, a certain flow rate, which is not fixed. It's varying in time. Then you also have the type of the reactor. Okay, you can have different types of reactors, different processes, and different process designs. Also, that will have a different impact on the N2O production. And then you have the operation, which is typically going to be, for example, set points of oxygen, etc., or cascade controllers, whatever. So all these things will have an impact on the amount of N2O that would be produced. So let's have a look at some evidence of this temporal variability. Okay, so what we see here are some pictures from two papers, and the references are shown below, where measurements of nitrous oxides were performed during the course of one day. And then you can clearly see, so N2O here is represented by the yellow symbols, that it's not constant in time, it's varying in time, and that it's related. But also you cannot really see very clear patterns. There are some patterns in there, but it's definitely not going to be completely fixed. So one thing that we want to also add to this, next to the temporal factor, is actually the spatial factor. We have seen that, or we talked about these metabolic imbalances by some extreme conditions. And actually the fact that a bioreactor is not a completely stirred tank reactor, as we will show later, you can have some of these extreme conditions even in locations where you don't expect it. So we believe that mixing is also a very important topic. So that brings us to a first key point of this webinar, that basically due to this complexity, it is really hard to assess and to effectively mitigate N2O emissions. So indeed, we have different factors that have an impact: the influent, the operation, the system type, and the mixing. So this also means that the assessment and the mitigation will also be highly plant dependent.